data, which are user data. Fine. Next, we'll be discussing the implementation of directory. How the directories, what are the different ways of implementing directory? The most simplest way to implement a directory is to use a linear list. Okay. Linear list is something like a linked list. That is, if you have if the system is currently having 10 directories, then just maintain a linked list. Directory 1 to directory 2 to directory 3, 4 up to 10. Using the linked list, the directory structure is maintained. This is simple to program, but actually it is a time-consuming approach to execute. In the sense that when you want to create a new directory, after creating a new directory, the operating system should check whether the directory name is a valid one or it's not a duplicate by browsing through all the existing directories, and it should ensure that there is no other directory with the same name already exist. Okay. So basically it takes a lot of time, right? Similarly, if you want to delete a directory also, you have to browse through the linked list and you have to identify that particular directory and then you have to delete it. You cannot directly go and delete, right? If the directory is 100th directory, then you have to go from first to 99 and then only you can delete. That is the drawback with the linear list representation of the linear list way of implementing directory. The next way of implementing directory is to use a hash table. So hash table, it is also one form of linear list with hash data structures. So what it will do in the sense, the user program will say that I want to access so and so directory. The user program the user program says that I want to access this particular directory. I want to access this particular directory. Okay, and then this information, this directory number, this whatever the directory the user program is trying to access, first it will be converted to some number. Basically, it is a name. Then it will be converted to some number, and it will go through a hash operation. After converting it to a number, it will go through one particular operation which is called as hashing. The hash operation, uh, after going through the hash operation, it will again give another number. It will again give another number which basically represents the block number of the particular file at which block it is stored. Okay. So now, for example, if it creates a block number 10, it means that whatever the file the user wanted to access, the file or the directory, initially whatever the user gives, it may be a file or a directory, whatever the user want to access, it means that it is available in block 10, then user can directly go and access the block 10. Okay. So this is how the hash table uh, uh, works. Okay. So basically, uh, what you call this hash will give a 10. 1 minute. Uh, yeah. So say this hash, after applying to the hash function, it gives a number 10. Okay. Then there will be something called as hash table. There will be something called as hash table. Okay. So here a different block number will be stored, like one, block number two, block number three, and block like that every block. So block number 10, it is in which particular track or sector that data will be available here. Now the hard disk can directly, now the operating system can directly access that particular sector. Okay. So this is how the hash table thing works. That is the user information, whatever the file name user gives, that will be converted to number, and then it will be performed a hash operation. As a result of the hash operation, whatever the value the hash operation gives, that will be used as an index to the hash table, and then the appropriate physical address will be taken to access the particular hard disk. Okay. There is a drawback in this hash table implementation also. As long as the as long as the number of files does not change, it is okay. But if the number of files increases, then the hash table size also will increase. Then accordingly you have to modify the hash function. This is one drawback. Otherwise, what you have to do in the sense, you need not modify the hash function, but some cases this hash function may create duplicates. Say for example, when the input to the hash function is 5, say it is creating 10. When input to the hash function is 2, is also it is creating 10. In that case, how will you manage? In that case, what we can do in the sense, this hash uh, this hash table should not directly point to the physical address. Rather, a pointer should be connected here. Rather, a pointer should be connected here. If the address is 5, if the actual the input, whatever the user want to access, if it is 5, then access this location, some location L. If it is okay, if it is 5, access this location. If it is what do you call, if it is something else, say if it is 2, then access some other location. Okay, so this is something like a, again here you should maintain a linked list for each of the index of the hash location, especially if there are duplicate values of the hash index value can be created, then a pointer, then a linked list should be connected here. So this is how this problem can be overcome. So these are the, generally these are the two ways of implementing directories are available. Next we'll be discussing about allocation methods. Here we'll be discussing like how the storage was allocated for files in the hard disk. So first what we'll be discussing is contiguous allocation. So it's a very simple technique. In contiguous allocation, what happens in the sense, the storage will be allocated in contiguous block. Okay, there will be a starting location and there will be a length. Starting location represents the starting block number and length represents the maximum number of the from that location how many block it will be allocated. Okay, so basically this is similar to what you call as mm, so this particular technique, for this particular allocation we need contiguous memory. Okay, so this is, you can see something in memory management. We have discussed two types of partitioning: fixed partitioning and variable size partitioning. So in variable size partitioning we faced a problem called as what do you call it, external fragmentation. The same problem can appear here also, because you need to allocate always contiguous blocks of memory. Sometimes what happens in the sense, for a particular file you may not have the contiguous blocks of sufficient memory. Okay, but there may be chunks of memory, at different locations which are available. If you club all the chunks together, the request which is made by this file can be satisfied. But actually, if you don't have continuous blocks, then that request cannot be satisfied. So that is called as external fragmentation. Uh, so that external fragmentation problem can appear here also in hard disk point of view also. Okay, so as how there the external fragmentation can be solved by using compaction, here also the external fragmentation can be solved by using compaction. Okay, so here compaction, how we do in the sense, if in a particular hard disk, if there are chunks of memory which is free, but as a stretch, we don't have a lengthy memory location to satisfy the request of a particular file, then what you have to do is you have to just copy the entire file system from one hard disk to another hard disk. When you are copying the file system to the second hard disk, you should copy it in a contiguous way. You should copy it in a contiguous way, not in different chunks. Okay, so in the first hard disk, maybe from first block to 10th block it is filled, then 10th block to 20th block it is empty, then 20th to 30th is filled, then 30th to 40 is empty. But when you copy this to the second hard disk, you will copy from first to 20, first to 10, then 11 to 20, like that continuously we will copy, so that at the end we will get the empty free space, and that can be used for storing new files. Okay, so this particular diagram clearly explains like how contiguous allocation works. So here you can see These are the file names. So there is a file count. It starts at block 0 and it has a length of 2. So starting from block 0 to length 2. So it occupies 0th block and first block. There is another file tr. It starts at block 14. It's a length 3. So it starts at block 14 and length 3. So it occupies 3 blocks, 14, 15 and 16. Then this file mail, it starts at block 19, length 6. So 19, 20, 21, 22, so 6, okay. Then file F, file list, it starts at 28 and length is 4. So that is from 28, 29, 30, 31. This, okay. Then file, there is a file F which blocks starts at block 6 with a length of 2. So it occupies 6th block and 7th block. So this is how the contiguous allocation works. But the drawback is, as we already discussed, it may create external fragmentation. The next method of allocating disk space is using a linked list. So linked list, when you use linked list, there is no external fragmentation. Uh, with a null pointer, okay, and there is no need for compaction. These are not required. So let us discuss how this linked list allocation works. So let us, this is how basically the linked list allocation works. So see this particular directory structure, there is a file named Jeep. It starts at block number 19 and it ends at block 25. Okay, so the starting block we know it is 9. Block, it starts at block 9 and ends at block 25. Starting block is 9. So ninth block contains some data. Along with the data, it also contains a pointer to the next block. So after 9, the head will move to 16th block. It will access the data in 16th block. After 16, the head will move to first block. It will access the data in the first block because that the 16th block is pointing to the first block. So every block will also have a pointer which points to the next block. And the first block is pointing to 10th block. Okay, and the 10th block is pointing to 25th block. In the 25th block, you see there is a -1. And also you know here it is the end of the block. Okay, so the operating system will stop accessing when it reaches the 25th block. Okay? So now here the memory need not be here, the storage need not be in contiguous blocks. It can be at different location also. Okay, so this is how the linked allocation works. This this directory structure can be further simplified. You need not maintain an end pointer. Only a starting pointer is enough, because the ending location will have an EOF representation as -1 or something. Okay, so that is what I mentioned here. So the directory structure contains only the file name and the starting block. So starting block is 217 and this 217 is pointing to the next block which is 339, and 339 sorry, which it is pointing to the next block which is 618, and 618 is pointing to the next block which is 339. In 339 there will be something like what you call end of file. So it means this particular file ends here, right? So there are two ways of representing. Either you can have an end block or you may not have an end block. Okay, because in the last block you can have some bits to represent that this is the last block of this particular file. This is how these linked allocation works. And the next is the indexed allocation. In indexed allocation, what we do in the sense, for every file, we maintain we maintain a set of pointers, not one pointer. For every file, you maintain a set of pointer. Okay. So in this example, what we are seeing in the sense, for each file, we are maintaining this many pointers: 1, 2, 3, 4, 5, 6, 7, 8 pointers are maintained. Okay, so you can, and so these pointers are numbered. Like say this is pointer 1, this is pointer 2, this is pointer 3, 4, 5, 6, 7, 8, up to 8 pointer. Okay, so when the operating system want to access the file, it access in this order. First, it will access the block of the first pointer. The first pointer points to the ninth block. Okay, where is ninth block? It accesses this data. Then it access the second block, which is the 16th block. Okay, where is 16th? Uh, the second pointer is pointing to 16th block. Okay. Second pointer is pointing to the 16th block. Yeah, it is here. Okay. And the third pointer is pointing to the first block, which is here. And the fourth pointer is pointing to the 10th block, which is here. And the fifth pointer is pointing to the 25th block. So this particular file is using only 5 blocks. It is not using all the 8 blocks. So the remaining 3 blocks are represented as -1. Okay. So this is how this indexed allocation works. The drawback with the indexed allocation is sometimes the file may be, my file size may be very small. I may be using only 2 pointers. In that case, remaining 6 pointers were wasted. Okay, that is one drawback. Or some other case, my file size may be very large. 8 pointers may not be sufficient. I may need 10 pointers or 12 pointers. In that case, this 8 pointers may not be sufficient. So these are some of the drawbacks with indexed allocation scheme, right? So that's it about different ways of allocating disk space for files, and that's it about this particular topic, file system implementation. Okay, so here we have discussed like how the files are stored in the hard disk and how it is accessed in a layered approach, and and how the and how the hard disk is partitioned, and what is a boot I mean what is a boot sector, okay, and how disk and what is an FCB file control block, and how the contents of the and how files are stored in the hard disk. Okay, that is uh, file system allocation, and also how directories are implemented. There are two ways of implementing a directory. One is using list, and the other one is using hash table. Okay? So these are the different things we have discussed in this chapter. So let us stop here. Thank you.